Hello students. Let us take some time discussing some problems from 5.4. I assigned many, and 5, 7, and 9 are kind of similar. 11 and 13 are quite different. I don't know whether I'll have time to do all those, but maybe one of them I could do. So from 5.4, let's select problem, let's see, 5, 7, 9. I don't want to exhaust any of those problems, so let me select something similar. Number 8. And it goes like this: ty double prime minus 2y prime plus ty is equal to 0. That's the differential equation. And let's solve this. The first step, of course, is to take Laplace transform. And let's take it. Okay, let's say this script t represent Laplace transform. Okay, we got the equation. And now let's work out these t's. What do they mean? They mean the derivatives. So get this t out. That means we have to take the derivative. And we have to change the sign. Do the same thing again. Remove this t means derivative. And we have to change the sign. Okay. Next. What is this L of y, or Laplace transform of y? That's capital Y of s. So we're going to take the derivative later. How about this Laplace transform of y prime? It is sy minus y of 0. How about the second derivative? S squared y minus s times y of 0 minus y prime of 0. Okay, let's go to the next stage. Let's take the derivative. This is capital Y prime. And this is all set, but y of 0, let's rewrite it as y naught, because this is supposed to be a constant, and y sub 0 kind of looks like we'll have to plug in something and do some work. It's supposed to be a constant, so y0, it looks a little bit more constant-ish. Okay, how about this derivative computation? This is just constant function, so it goes away. And this is just linear function, so it just becomes y of 0. But then again, let's take y of 0 as y sub 0, constant. And then we have to take this derivative. We have to use the product rule. So this is 2s times y plus s squared times y prime using the product rule. And of course, if you took the derivative, we don't have this dds any longer. And here we go. Okay, from here, let's manipulate this thing just a little bit. Let's see, how about y prime part? Negative s squared and then negative 1. So if I put those together, I'm going to get negative of s squared plus 1 of y prime. How about the next one? Negative 2sy, another negative 2sy. So put those together, I'm going to get negative 4s y. How about the constant part? we have negative negative plus y naught. And how about here? Negative negative plus 2y naught. So put these together, we can write it as 3y naught. So what did we end up with? We got a linear equation, a first order linear equation of y prime. If you solve it, then you will be able to identify what capital Y is, and then take Laplace inversion, you're going to get the answer. Let's call this part as step 1 of the solution. We got Laplace transform and then get the differential equation of capital Y. Let's go to the next step, but before that, we have to have a reminder. This is the last step. Okay. Step 2, let's work this one out. Let's flip this 3y0 to the other side. Too many negatives, so let's change all those signs to positive by multiplying -1 to each term. Okay, and then one more step. Divide everything by this s squared plus 1. This is what I'm going to get, s squared plus 1, the coefficient function, and over here s squared plus 1. This is a standard form, which is written in y prime plus p of s y is equal to f of s form. And in this case, what do? We take the integrating factor, which typically is represented as mu in our textbook, which is exponential of integral of p of x, p of s, ds, and we're going to multiply this to each term. Let's do this computation. Come on. Okay, all right. I need some bigger font. Okay, all right. What is p of s here? Right here, and let's use that. 4s over s squared plus 1. Okay, how do we calculate this integral? Please note that numerator is more or less the derivative of the denominator. What am I talking about? 4s can be decomposed into 2 times 2s, and now this numerator is the derivative of the denominator. So this whole integral becomes log of s squared plus 1. If you apply the log rule, log of s squared plus 1 squared, and log and exponential cancel each other out, you're going to get the answer. S squared plus 1, that is your integrating factor. So that is your integrating factor. Oh, I'm forgetting this squared. Okay, this is a derivation down here, but it's a long process, so let me just hide it behind this cell. And then now that we got the integrating factor, multiply the integrating factor this equation, and then let's work out. So multiply the integrating factor. and then multiply the integrating factor. Okay, looks complicated, but we can reduce it. Left-hand side, this is something we have been doing time and time again. If you just apply product rule backward, then this is just product of those two things. So this whole thing is, as a matter of fact, nothing more than integrating factor times y put together, and then the derivative of it. Right hand side, well, this is a computation. 3y naught, and this square and then down there cancel each other out. I'm gonna get, no denominator, s squared plus 1. Okay, we have it. This derivative is equal to that. So if we take the antiderivative of both sides, we are gonna get what we want. S squared plus 1 total quantity squared times y is equal to antiderivative of this thing. Three y. Okay, we have it here. And let's calculate this. Constant, I can always pull outside. Let's calculate this. 3y naught times 1/3 s cubed plus s plus some constant. Simplify a little bit further. We have y naught and then s cubed plus 3s plus 3k. Okay, that's gonna be the right hand side, fully calculated. If you divide away the left hand side by this s plus 1 squared, you're gonna get what you want. Capital Y is equal to y naught times s cubed plus 3s plus 3k divided by s squared plus 1 total quantity squared. What is this quantity? If you decompose a partial fraction using some computer algebra system, then you're going to be ready to apply Laplace inversion. Let's call up to here as the step 2. Let's copy and paste this thing for the next step. Okay, let's go with step 3 of the problem. Oh, by the way, okay, that's the right place. Okay, let's calculate this thing and try to calculate this using paper and pencil. You're gonna regret it. And let's calculate this thing using computer algebra system. It didn't understand what to do. That's because there were too many constants. And y0, we can remove that. Let's see. Does it look better? Well, to a certain degree it looks better, so okay, let's work it out. So this is y naught times let's see, s over s squared plus 1 plus 2s over squared plus 1 plus 3k over s squared plus 1. As a matter of fact, this denominator squared. I forgot that, and I forgot here as well. Well, this is a partial fraction. I'd like to have a little bit bigger font. And we can apply Laplace inversion here, and you can find out what you want. What's going on here? Okay, and that's not what I want. I want is copy and paste this one, this mathematical computation over there, so that we get that. And then let's apply Laplace inversion. Let's see. That one I recognize. That two I recognize. And then this one I don't. So what do you get? Excuse me. Y of t is gonna be y0 times Laplace inversion of this blue, s over s squared plus 1. What is it? I think it is cosine, but I'm not so sure, so let me stop this recording and look up the table. Yes, correct. This is cosine. How about this one? 2s s squared plus 1. Oh, wait a minute. Is it sine or cosine or... I forgot again. Let's see. S over... okay, that's that. And then this one I think is sine. I stopped recording and then looked up the table from our textbook. I couldn't really find it, so let me use computer algebra system. Laplace transform of t sine of t oops, typo there, sorry about that. Yes, it's correct. Okay, this is correct. And then this one I do not recognize. And this part has its own constant, so it's gonna be on a constant times something. And what does this thing tell me? That means the equation is, the desired general solution looks like this. That means the desired general solution looks like this. And the blue and red, they are both tied to the initial condition y0. So here goes one solution, and the second solution, which was supposed to be linearly independent. Laplace transformation method found out only one of them, not the second one, so I'll have to stop here.